2.6. Other types of equations. First of all, let's list what we know. Let's list what we know. Because we have to look at polynomial, radical, absolute value equations, quadratic in form, rational, but we know that already, graphically, which I'm going to show you. Okay, so these types. So what do we know so far? We know linear, quadratic, and we have 4 methods here, and I will review those 4 methods with you. Number 1, factoring. We've been doing this already. Number 2, taking square roots. Number 3, which we just reviewed, completing the square. And number 4, quadratic formula. Let's take a moment. So linear, we know. Quadratic, we're going to review a little bit. Taking square roots and quadratic formula, a refresher. Next, we know what? What we had on the quiz today. What type of equation was that?
Complex.
Rational, right? Equation. And now we are going to look at equations with fractional exponents. With fractional exponents. We are going to look at polynomial equations. And you could say, but what about linear and quadratic? Aren't these polynomial? Yes, they are, but we are talking about higher degree here. We are going to look at radical equations. Radical. We are going to look at absolute value equations. We are going to look at equations that are not quadratic, but are quadratic in form. Quadratic in form. Later on, this is for much later, I shouldn't say much later, but later on we will talk about log, exponential, trig equations, and so on, and so on, and so on. So for now, let's go through this list. Linear, I'm not going to go back. Quadratic, I would like to not discuss factoring and completing the square because unless you want another example of completing a square, I would like to give you an example from taking square roots and quadratic formula, and then these are done. These will be done, and then we'll continue with the rest. Okay. So let's see if I have an example here. No, I don't, so I'll make one up. So let's suppose I have x plus 1 squared equals 4. In other words, a completed square on the one side and just a number on the other side. This is a typical situation for taking square roots, in which we take the square root from the left and the square root from the right. But remember, we expect 2 solutions. Do not forget to write plus or minus on the other side. Not to be understood that the square root of 4 is plus or minus 2. That would be a huge error. The square root of 4 is not plus or minus 2. The correct statement in between should be this. This is the correct statement. We omit this and we jump directly here. But please do not remember ever that this is plus or minus 2. The plus or minus come from this side, from the absolute value, as we've noticed half an hour ago or 20 minutes ago. Okay, so then the answer would be, I move 1 to the other side, -1 plus or minus 2. I have to separate the solutions. Can anyone give us 2 solutions here? Yes, so -3 and -1. So what have we learned about taking square roots? Only if it's appropriate. It's appropriate. Why? I have everything condensed with x in one perfect square and just the number on the other side. And that's a typical situation. Here, this is not a typical situation. You cannot do this. That's not allowed. It won't solve any problem. Will not solve the equation because you have x on the side. You have to have a plain, simple number. It can be 0 or negative, and a completed square with x on this side. If x is on this side, we cannot take the square root. You have to complete the square first. So that's the method of taking square roots. Should we refresh our memory on the quadratic form? Yes, please.
Wouldn't it be x equals -3x equals
I'm sorry, thank you. Thank you very much, my apologies. Yes, -1 plus 2 and -1 minus 2. Thank you, please correct that, my mistake. Thank you so much, Ryan. Okay, perfect. So do we need to refresh our memory in the quadratic formula? Anyone? Okay, perfect. In that case, yes? Okay, you can change your mind later. So I would like to continue with polynomial equations, radical equations, and then rational exponents, and then absolute value and quadratic in form. Okay, ready? So the next one is polynomial. Polynomial equations. I'm going to choose, I selected what they selected, so why not? Let's start with, I don't know, 19. I just circled what my colleagues selected. 19, this is from the book, page book. And that is 5x cubed plus 45x equals 2x squared plus 18. Why is this a polynomial equation? It's because we see a polynomial, and what is its degree?
33.
Awesome, thank you. Well done. This is indeed degree 3. I take notes when I solve a problem. I identify the degree is 3. How many solutions do I have to get? Mandatory the degree. Mandatory the degree. If the degree is 15, I have to come up with 15 solutions. They may repeat themselves, so I don't care, but I have to find 15 solutions. Okay, in this case, degree is 3. Okay, next step would be to move everything to one side and set it equal to 0, which means 5x cubed plus 2x squared, I'm sorry, I meant to write minus, plus 45x minus 18. So I'm correcting that. So 5x squared minus 5x cubed minus 2x squared plus, do you need my help? Do you need my help?
Oh, no,
Is it here?
I have it.
Okay. How many terms do we see here? What is the only option we have? By? Someone said it. By grouping. Very good. Thank you, Bill. Okay. So let's look at the first two. Notice that I intentionally covered the other two. And please tell me what you factor out.
Squared.
Very good. What is left in parentheses?
5x minus 2.
What do I have to see coming out of the other two? Otherwise, I can't continue. And I will not draw the conclusion that this is not factorable. I may have to group the first with the third and the second with the fourth. I may have to try to factor the first and the last and the middle two by themselves. So what do we have to see in parentheses coming out from the other two? If it's not a 5x minus 2, I'm not on the right track. So I need a sign and a factor, without which I can continue. What do I factor out? Sign?
9.
Sign?
Oh.
Very good. If I omit the sign, I will never be able to continue. Okay, perfect. So now, what comes out? What is the common factor now? 5x minus 2, and what we have in parentheses? X squared plus 9. Remember how many solutions we have to write? Okay, for now we have 5x minus 2 equals 0, and you will give me x. And x squared plus 9 equals 0, and we'll talk about it in a minute. So just give me the first x. Exactly. Move the negative 2 to the other side, it becomes positive, and divide by 5. So x indeed is 2/5. Now, let's take this equation aside. And this is x squared plus 9. That's why I wanted to review taking square roots. I will separate x squared equals negative 9. This is a perfect example of taking square roots method. And we have x equals, I have to write plus or minus, not because the square root of negative 9 is plus or minus, but because the left-hand side is the absolute value of x. And what do I write now? Because I have to refresh your memory on this. This is the square root of negative 1 multiplied by the square root of 9. How do we call this? Excellent. What is this? So the answer is 3 plus or minus 3i. And we have those three solutions that we were looking for. One is real, the other two are imaginary. So this was an example of a polynomial equation. Questions, please. Questions, please.
So the answer would just be 2/5.
1 plus 2 more, a total of 3. Is that okay, everyone? Perfect. So let's consider now, we want to continue with radical right now or absolute value? Absolute value it is. Okay, so let's take a look at number 31. If you want to choose, please do, anytime. 1 minus 4x in absolute value minus 1 equals 5.
Is that 31 in the book?
Yes, book. All of them from the book for now. Still page 141. Good. So this is indeed what type of equation? Oh, I'm sorry, I didn't write the title. Sorry, my apologies. Absolute value equations. That's our next step. So the answer is it's an absolute value equation. What do you think we need to do first? And I would like to write down two keywords that we will talk about all the time. Factor, simplify. Sometimes factoring is what we need to do. Sometimes simplifying is what we need to do. Sometimes both at the same time. So then, in this case, how do I simplify this equation? There is nothing to factor, obviously. So I have the absolute value 1 minus 4x equals 6 indeed. So simplifying or cleaning it up, that's what I meant. I move negative 1 to the other side, it becomes positive. Now remember, whenever we talk about an absolute value, how many options are there? Exactly 2. What are the options? The options are 1 minus 4x equals 6. And then the other one with minus, but I'd rather put the minus on this side by multiplying both sides by negative 1. So remember, please, every time you see an absolute value, you know you are going to see or expect 2 possibilities. At least that's the first step. They may turn out to be more than one, than two. So now I solve the equation, the linear equations. Negative 4x equals 5 and x equals negative 5/4. Certain absolute value equations have infinitely many solutions. Others 2, others 1, or none. There are several options here. Or negative 4x equals negative 7, or x equals 7/4. I do not see absolute value equations here with 2 absolute values, so I'm not going to insist on that. Any questions, please? Do we understand how we got the solutions? Yes? Yes?
Say we did that one.
Say it again?
Say we did the same problem, but instead of having equal sign, we did inequalities. What?
A lot. We're going to get to inequalities in 2.7. Very good question. Excellent question, right here. Linear and absolute value inequalities. If you want to wait, possibly today, we'll see. We're going to get to this. I doubt that we're going to get to it today, but yes, I'm going to answer your question. A lot will change. Because it will be an interval, not a value or two. Okay. Do we need more examples of the absolute value equations? Yes? Yes? Are we okay?
Yes. Yeah.
Yes? Okay, perfect. So let's look then at radical equations. When we looked at rational equations last week, I said I do not consider them trivial. This is another type that I do not consider trivial. Okay, ready? So let's choose. Let's start by looking at radical equations with one radical, and then the most complicated ones with two radicals. So let's start with a easy one. Let's say, let's say 23. So 23, page 141 from the book. And that's the square root of 3t plus 5 equals 7. We want to apply a procedure that removes this radical. Yes, but I want a cube. You insist on squaring, but I want a cube. Will my cube work? Of course not. Why would my cube not work? It's because the square root is what power? It's a fractional exponent. Exactly. So 1 over 2 times 3 will not make it go away. So it has to be 2. Very good. Awesome. So remember x, the square root of x is x to 1/2. In order to remove the square root, we will have to square both sides. What if the cube root is in the problem? That means x to 1/3. This is when we do what to both sides? Exactly. Exactly. So in order to just remember, this is very important. A lot of my students don't remember this, that the square root or any root is a fractional exponent. Any radical is a fractional exponent. Any radical, the fractional exponent. Okay, so then you square, the left-hand side becomes, the right-hand side becomes
49.
Excellent. This is back to a linear equation. I have 3t, I subtract 5 from both sides, and I get what, 44? Okay, so then t equals 44 over 3. Keep in mind, this comes with, I cannot put enough question marks. What does that mean? No, because we squared, not taking square roots. Why do I have so many question marks in there? If I move a term from one side to another, like we did here, I moved 5 to the other side, became negative, or I subtracted 5 from both sides, and did I change the equation or the solutions by subtracting 5? No. What if I decide to add 2t to both sides? Will I change the solution? No. But when I square both sides, the answer may not work in the original problem. It's not 100% legitimate operation. moving terms around, dividing by 5, multiplying by 3, by -1, legitimate. Squaring both sides may result in solutions that do not work in the original problem. That's why all these question marks. To make myself a note, a mental note saying, don't forget, you square both sides. Go back and check. It's a must. It's part of the problem. It's not guaranteed that this works in the original problem. So then, must check the prospect solution.
Is that because they can't be negative? Whatever's inside the square root.
No, it's because, here's an example. Let me finish the sentence and I'll give you an example. It's a very good question. Must check the prospect solution or solutions back in the original problem. So here's the answer why. Let's say I have the equation x equals 2. So let me read this back to you one more time. Must check, it's part of the solution. Must check the prospect solution, in this case 44/3, back in the original problem. So let's say I have the equation x equals 2. And I decide to square both sides. And you will say, why? And I will have no answer, because I will never do this. But bear with me for a moment. So let's suppose we square both sides. What do I get? How many solutions does this equation have? And what are the solutions? But look, I started with the equation x equals 2. Will this work here? So this is a principle of the principle of square roots or raising to powers, which is not a 100% legitimate operation. It may result in what we call extraneous solutions. This has nothing to do with the original problem. So anytime we square both sides, I have to be honest, when you cube or take to the 5th power, everything will work. But you still have to check, make sure. But every time we raise to the 2nd power, the 4th power, solutions may or may not work in the original problem. So when we go back, 44 divided by 3 times 3 is 44. 44 plus 5 is 49. Let's go to 49 is 7. So yes, I went back and I checked and it works, and that's the solution. But I have to go back and check. Okay. Let's look at 25, which is slightly different. 12 minus x equals x.
We eventually do one of these that didn't have a solution. So we can see.
Yes, of course. Well, I'm sure we'll hit some here. Yep. Okay, it's completely cleaned up. You can't do anything. So how do we continue? Very good. So the left-hand side is, and the right-hand side is? Good. Now, in the previous problem, the radical equation collapsed, we say, into a what type of equation? Indeed, awesome, linear. But now this radical equation, after squaring both sides, it collapsed, we call it, into a, how many solutions do we have to write? 2. Very good. So remember, we have x squared plus x minus 12 equals 0. We have to set it equal to 0. I prefer, in this case, moving everything to the right so I don't have to multiply by -1 because I don't solve any quadratic equation with a negative leading coefficient ever. It's up to you. You can move everything to the other side and then arrange it in descending order and then multiply by -1. Okay. The factored form of this is excellent. So x equals -4 and x equals 3. And I can't put enough and big enough question marks. Do not check here. This is not the original problem by any means. The original problem is this. This is the original problem, and that's where I go back and check. With the square root, of course, I swallow the square root. Sorry. So, -4. 12 minus -4 is 16. 16, the square root of 16 is? The right-hand side is negative 4. Because I plug in negative 4 here, I have to plug in negative 4 here. Flynn, are you working on these problems? Okay, good. So what do you say about x equals negative 4? Of course not. Negative 4 cannot equal negative 4. Done. So now I plug in 3. 12 minus 3. The square root of 9. And the right-hand side is 3. Would you accept x equals 3?
Yes.
Of course.
So is the negative 4 just a no solution, or is it kind of extraneous?
Extraneous solution.
That counts as extraneous.
Yes, yes. But if 3 didn't work, I would have said the equation has no solutions. But I still have a solution. It works. 3 works. Okay, I know we have 7 minutes left, so let's choose a 2 radical equation. Ready? And then we'll probably have to stop after that. Okay, so 27, still on page 141 from the book. And we have the square root of 3x plus 7 plus the square root of x plus 2 equals 1. Whenever this happens, which means a radical equation with 2 radical expressions, it is wise, not mandatory, but wise to separate the radicals. Why? It will be easier to square, and you'll see in a moment why. So I'm going to take this radical to this side and write 3x plus 7 equals 1 minus the square root of x plus 2. I know this is a torture already, because I'm going to ask you again, a binomial squared has, very good, it's a trinomial. You will see in a moment why I'm refreshing your memory on this. So now please tell me what will be next. Same thing, nothing different than before. We square the left-hand side and we square the right-hand side. Can anyone give us the left-hand side, which is not difficult? Very good. I'm preparing this to take attendance. Okay, so the left-hand side is, because I'm logged out, I'm always logged out. Okay, so now be very careful. This is the first term, and this is the second term. And I need 3 terms. 1 minus 2 times the first times the second plus the second term squared. That's why we wrote it here. What do I write? Very good. Do we all agree with this step? First term squared plus 2 times the first times the second plus the second term squared. Is that okay, everyone? Yes?
So is the 2 in front of the radical just a exponent?
2 times the first times the second. It has nothing to do with the exponent. Yeah, nothing to do with the exponent. Ready? That's why I put it here. The first term squared minus 2 times the first times the second plus the second term squared. Yes?
You write it out, but I can't see what you're doing.
Yeah, she did a short. She did like 2 shortcuts.
Okay. A plus b squared, or a minus b squared, is the first term squared plus 2 times the first times the second plus the second term squared, or minus. So a is our first term, b is our second term. So then I copy. The first term squared will be 1 minus 2 times the first times the second, which is this term right here, and then plus the second term squared, which is x plus 2. I want us to move away from foiling. If you foil, you're going to get full credit, of course. But then factoring will become a problem. Okay, so now the next step. Can anyone dictate?
One of my terms.
Yes. Combine like terms and also isolate the radical. So negative 2, the square root of x plus 2. Everything else moves to the other side. I have a 3x on the left, and I'm bringing over 1x. What does that mean? Careful, because when I bring it, I have to change its sign. Yes. I have a 1 plus a 3 plus a 2, which is a positive 3. I have a 7, but I'm bringing over a negative 3. Positive 4. Excellent. Now we want to simplify. Sarma is here, Vanessa is here, Michael is here, Dante is here, Aaron, he told me he wasn't feeling well. Justin. Okay. Rima is here, and Jane is here, Elma is here, May is here, okay. Hatu, yes. Kyle. Bailey is here, Lizzie is here, Young is here, Alex. Glenn is here, Connor is here, Robert is here, Ryan is here, Lauren is here, yes. Arthur. Okay. I have to confiscate a phone. When you come in, you'll put it on my desk. Please. The other Connor is not here. Jonathan and Emmy. Very good. Yes. Yes, of course. Yeah. No, I already know.
Other comments.
Oh, yeah, I'm sorry. Oh, sorry. Okay. Sorry. My apologies. I corrected it. Okay. Good. So I want to simplify, of course, both sides by. Both sides by. Indeed. So then x plus 2 equals negative the square root of x plus 2. Are we okay so far? Okay. Next step, please. Square both sides again. We are squaring a binomial. How many terms will you give me here? Very good. Please dictate 3 terms on this side. Here's the formula. We reviewed this on the first day of classes. So please give me 3 terms.
X squared plus 4x plus 4.
Excellent. The right hand side, please. Excellent. Thank you. Imran? Yes.
Then can we break this x plus 2 with x plus 2 power 1 by 2 and then x plus 2 power 1 by 2?
You mean x plus 2 like this?
Yes.
It will not help.
Into like x plus 2 and same power.
No, this is only 1. Oh, yeah, you mean the power. Yeah, but I'm just going to get x plus 2. There is no need to do that.
No,
It's not a
on the
mistake.
other side, then,
This one?
yes, on the other side.
On this one?
Yeah.
Yes, but we are not foiling anymore. We made a huge leap forward. We're not foiling anymore. We're done foiling. You can if you want to, but I'm hoping that, yes, Flynn?
Couldn't you divide it by negative to get rid of the negative?
This one?
Yes.
But if I divide or multiply, then I'll have here. I didn't accomplish anything. I prefer this. So then this is quadratic. X squared plus 3x plus 2 equals 0. Please factor. I know we are 146. So we have x plus 2 and x plus 1. And please check negative 1 and negative 2. You have to go back to the original problem and check. And let me know next time if both work or none